channel. Meta just released their latest model called llama 3.2 versions, which is the latest model, and they have just released their two model, and each contain two version of its according to their parameters. For lightweight model, they just released two version, 1 million and 3 billion parameters, and for multi-language or multi-language vision models, they release 11 billions and 90 billions parameter models, and they can sports 128k tokens length, context length, and the two largest model of llama 3.2 to sports image captioning, document level understanding, charts and graph, including image captioning and visual grounding. Model 1 billion and the lightweight 1 billion and 3 billion model are highly capable with multi-language text generation tool calling abilities. So in this video, we are going to learn how to fine tune them on our custom dataset on Colab notebook. So let's write the code. So we are using the official notebook released by Unsloth, and first of all we have to uh, install our necessary libraries, which is Unsloth and its 90 versions, and then uh, using the fast language model, we just access this llama 3.2 model, which is instruction based model, not the base model. And uh, in this code you have to set some parameter, maximum sequence length, and 4-bit load in 4-bit data types and quantizations. Next, in this code we are setting some LoRa configuration. These are the target module. We are going to fine tune them, and the R stand for low rank matrix. Higher the ranks allow more expressive power, but increase in compute requirements. And the and the LoRa alpha, and the LoRa alpha control the scaling factor, scaling, and it adjusts the contribution of low rank matrix to final output of the model. And the dropout set to be 0. And no next we will look at the data preparation steps, and we need to convert our data according to this prompt. Note, if you are using their instruction based version of the model, then you have to write down the same, then you have to prepare your data according to this chat template. And if you are using their base model, you have to write down your own chat template. So for this tutorial we are going to use fine tune 100k dataset, which is available on Hugging Face. And this is fine tune 100k dataset, and it is collected by multiple resources. So I just set up the chat template according to our model requirement. And Onslaught supported different chat template like Mistia, llama, and different models. And then load the model and just pick the training set of the data. We are standardize our data set from this to this, and finally map them and here, and just look at some data. So I access the fifth conversations of the dataset, and it is here. How similarly this one text, which is the actual column of the dataset. And next we are going to train our model, importing our supervised fine tuner from TRL and some other module like training arguments and data collector for sequence to sequence. And we just set up our model, tokenizer, dataset, and the actual column, and the maximum sequence length that we just have mentioned here. Yeah, this one. And then the number of processor at a time to process the data, which is 2. And then set up some training arguments uh, per device train batch size and gradient accumulation and the epochs and the maximum steps. Uh, don't confuse between the training number of training epochs and maximum steps. Either you can set training epochs or maximum steps to do. You set the training epochs, it will uh, run the code. It will run the code for once for a whole dataset, which will take longer time as we have larger dataset. And then we define learning date and some other parameters of training arguments. And then we just use our unslot train on completions method to only train the assistant output and ignore the loss on the user input. Then then we just look at how the tokenizer looks like in the dataset. And similarly this ones, we are training our model and calling the trainer class, and it just reduce the loss. And then we are set up our inference code from unslot template and calling our model. uh, and then we set up our inference code to run the inference on train models. And we are setting our chat prompt template, and note that llama 3.1 and 2 have the same chat prompt template based on their versions we are using. And I just set up some questions here and apply the chat template tokenizers, and it's returned the result here. That's it good. You can also use a text streamer for continuous you can also use text streamer for continuous inference, so you can see the generation token by token instead of waiting the whole. So this is all the code. And finally we are saving our model locally. And if you push your model on Hugging Face, then you have to write down your uh, token. And next we are reloading our model that we just saved with LoRa adapters. And in this code we are loading our models that we just saved named LoRa model, and put some question on that, and the answer is the Eiffel Tower located in the heart of Paris stand out among the cities. And finally we are just saving our model into gguf format. So this is all the code that I write to save the model to gguf format. So that's all, guys. We have just fine-tuned our llama 3.2 model on our custom dataset. I hope you like my video.